Alright, welcome to a lesson on inscribed angles and circles. So, who's ready for some theorems? Sorry, we're going to start with definitions. So, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. An intercepted arc is an arc that lies between two lines, rays, or segments in a circle. So here we have our inscribed angle in red and our intercepted arc in blue. This is the same definition we had for intercepted arc, we're just looking at it again. So we can have intercepted arcs whenever we talk about central angles and whenever we have inscribed angles. Two more definitions. An inscribed polygon is a polygon whose vertices lie on a circle. And a circumscribed circle is the circle that contains that inscribed polygon. So we have a purple triangle inscribed in a circle. You notice that all the vertices of that triangle are on the edge of the circle. Theorem time. The measure of inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. So, central angles are the exact measure of the arc. Inscribed angles are half the measure. Which begs the question, if I know a central angle and I'm trying to find the inscribed angle, can I? Yes, I can, because the central angle and the inscribed angle would have the same formula that we have right here. So if I knew this was the center and I wanted to find x and I only knew this, I could if I knew what y equaled. So don't forget that. So our formula is x equals 1/2 y, or y equals 2 times x. So let's get a little practice. Here on the left we have an inscribed angle that we're trying to find and the intercepted arc. We know that x degrees equals 1/2 times y. So x equals 50. On the right, we know the inscribed angle and we're trying to find the intercepted arc. And we know we get to double the inscribed angle, so y is 60. The inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So, in the picture we have angle ABD and angle ACD, which are inscribed angles, and they both intercept arc AD. If they both intercept arc AD, then angle ABD is congruent to ACD. And this kind of makes sense if we think about it. Let's say that AD, the whole thing, was 50 degrees. Well, ABD is the inscribed angle, and we just learned that inscribed angles are half the arc, so ABD would be 25. Well, ACD is also intercepting that arc, therefore it would have the same formula, so it would be half, which would also be 25, and we know that if things are equal, then they're congruent. So there we go. We don't have to do a statement reason proof, we just talk that proof out. Inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the circle's diameter. So, we know we have a right triangle inscribed in a circle. So if we have this right triangle ABC inscribed in circle P, then AC is the diameter. So the hypotenuse has to be the diameter if you have a right triangle inscribed in a circle. The converse to that says that if one side of an inscribed triangle is the circle's diameter, then the triangle is right, and angle opposite the diameter is the right angle. So, we don't know what kind of triangle it is. But we look and we say, okay, I have a triangle inscribed here in this circle. I notice that AC is the diameter. Well, if AC is the diameter, that means that ABC has to be a right triangle, and my angle B has to be the right angle. Now, I'm going to go ahead and let you pause the video and try to figure out why is angle B the right angle. Okay, let's think about this. So angle ABC here, that's an inscribed angle. And the intercepted arc is, I should probably use another color, shouldn't I? The intercepted arc is right here. Well, if this is the diameter, it means it cuts the circle in half, which means this is 180 degrees. This is 180 degrees, and we take that in half, that gives us 90 degrees. So there you go. Inscribed quadrilateral theorem. So our last theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So ABCD here is inscribed if and only if the measure of A plus the measure of angle C is 180, the measure of angle B plus the measure of angle D equals 180. So its opposite angles have to be supplementary. If you see that you have a quadrilateral and the opposite angles are not supplementary, even if it looks like it's inscribed in the circle, it's not. There we go.